In this video, let us talk about systems. Let us introduce an introduction to systems. So first, what is a system? Let us consider a motor. Let us say we are having a DC motor, and what I have drawn is the armature, and then you have the field. So the flux in the field is in this direction, and the flux in the armature is in this direction. So the armature flux and the winding flux, the field winding flux, are at 90 degrees. That is how the motor is designed, so that the angle between them is 90 degrees. It's nearly 90 degrees. So the torque is maximum. Torque is nothing but armature flux and field flux and the sine of and sine of 90 degrees. So 90 degrees sine is 1. So you have a maximum torque when the armature flux is at quadrature with respect to the field flux. So when we apply a voltage, suppose we apply a voltage, and when we apply a voltage, a current is passed through the winding, and this voltage will be equal to the back EMF that is generated within the armature plus the voltage drop plus uh, the drop in the armature. Let us, for the sake of discussion, let us omit the brush losses. So the back EMF can be derived from this equation is equal to k times psi omega m, where omega m is the speed. So when I apply a voltage, there is a back EMF is developed in the armature, and because of the once the back EMF is developed, it leads to a torque which actually causes the rotor to rotate, whereby there is an increase in speed. So when I increase the voltage, there will be an increase in speed. So the voltage can be thought of as an input, and the speed omega m of the rotor can be thought of as an output. So essentially the motor and the field winding constitutes a system, a physical system, which can mathematically modeled, as I have shown in this. This is the mathematical model of the motor system. So a physical system has a mathematical model. Therefore, we can write it in the form of a block. So the physical system can be written in the form of a block, to which an input, a voltage, is given, and we get an output y of t, which is nothing but speed in our case. So this block constitutes a system, and is usually has a mathematical equation which is called the system function. So it has a system function or a transfer function. So this function, the system function or the transfer function, is transforms the input into an output. Okay. So this is what a system is. A system is a mathematical model of a physical model which helps in transforming an input, which could be a time varying, and an output which also could be a time varying quantity. So this in short is what a system means. So next let us try to classify system. What are the systems, different ways a system can be classified? Classification of a system. The system can be classified as continuous time system and discrete time system. So what is continuous time system? A continuous time system, let me illustrate what is meant by a continuous time system. So we have as usual a transformation block. Okay, I apply an input. The input is continuous in nature, continuous time. It is a continuous time signal, and the output is also a continuous time signal. So a system which actually transforms a continuous time signal and the outputs a continuous time signal is known as a continuous time system. Whereas a discrete time system, it takes a discrete sequence as the input and it transforms it into a discrete output. Sometimes you may have a continuous time system which is passed through ADC, and then it is converted into a discretized sequence, and that sequence is passed through a digital system. This is DTS, and the output is again a digital output, which can be converted into a continuous time signal using. So this DTS can be a computer which processes the discrete time sequence and it outputs a discrete time sequence. This sequence can be converted into a continuous time signal using a DAC, that is